Hey guys, this is Ashank David, and in today's video, we are going to talk about NumPy operations. In the last video, we have learnt about NumPy indexing, and we have talked about how we can perform different types of indexing operations onto NumPy. So if you haven't watched that video yet, I will give the link in the description below, as well as I'll give the link in the I button as well, so you can go ahead and watch that video also, because this video is somewhat kind of extension of that video only. So in order to understand how arrays are working here, you need to first go through the previous videos, right? So before I start this video, I would like to request you people to please like, share and subscribe to our channel Coders Arcade, and don't forget to press the bell icon so that you won't miss any future updates. So without any further ado, let's get right into the topic, guys. So today we are going to talk about NumPy operations. Now, when it comes to NumPy operations, there are different types of NumPy operations that we can perform. The first one is going to be array with array that we are going to learn in this video. And the second one is going to be the array with a scalar. So we'll understand what exactly a scalar is in this case. And we will perform some scalar operations also. And then at last, we are going to perform universal array functions. Also in this video, I am going to tell you about a difference between an error and a warning in NumPy when it comes to working with Jupyter Notebook. So without any further ado, let's get right into the topic. So the first thing that I would like to discuss you about is array with array operations. To do that, I would first, so I'm going to say import numpy as np. And in this case, I'm going to run this. So numpy is included into this, and I'm going to create an array. So to do that, I am going to say arr equals to, and I'll say np dot arrange. You already know how to create a array now. In this case, we are creating a vector. So in this case, I'm going to say I want numbers from 0 to 10. So for that, I need to pass 0 to 11, right? I ran this code and we created the array. And in this case, if I right now arr, if I print this arr, you can see that we have got a nice vector in this case. In this case, it is a 1D array. All right. So I've printed that, and let's move on to now array with array in this case. So let's say I want to perform my first array with array function into our notebook. So the basic array with array is, say suppose I have an array of arr. We already created this arr, and if I add this arr with the arr itself, this is going to be array with array function, array with array operation. The basic arithmetic operations you can perform with different arrays by just adding or multiplying or deleting or subtracting in this case for different with different arrays. You can perform different operations like that. And this is what we call as array with array operations. Okay. Now when I run this code, you can see that it added all the elements into first array with the second array elements in this case, and we got the result. So 0 plus 0, 1 plus 1, 2 plus 2, 3 plus 3, 4 plus 1, and so on. You can understand. Similar to that, I can perform some subtraction operation also in this case like this, and it gave me the values by subtracting all the elements from one array to another array like that. Now, note that I am using the same a single created array that I have created here. You can have multiple arrays also into your program, and then you can perform operations on different types of arrays. Okay, so that is also one thing. Then you can perform array multiplication also. So I said ARR into ARR again, and this is going to give you the multiplied version of the array. All right. So these are some of the operations that you will perform as array with array. So I hope you've understood this very well, guys. If you have any doubts, you can tell us in the comment section below. The next thing that we are going to learn about is array with scalar. Now, what is this array with a scalar? So if I tell you about what is exactly a scalar is going to be a single number or element which you are going to add into the whole array as a whole for all the elements in this case. For example, if I write here ARR plus 100, this 100 is a scalar value which will get added into the whole array. Now you might think that it might append, this 100 might get appended into this array. right? But not like that. It's not like that. Actually, this 100 is going to get added in all the elements from 0 to 10. So in this case, if I run this code, you will see that 0 got added to 100, 100 got added to 1, and similar to 2, 3. All the elements into this array got added with 100 in this case. And in this case, we got a resultant array like this. Now, if I want to do multiplication also, I can do multiplication as well. So this is scalar multiplication. Similar to that, if I want to perform some operation, I can perform some operation on scalar like this. Okay. If I want to say all the elements into the array shall be to the power of 2, I can just say ARR, I can say double star, Python exponent operator, and then I can say 2. And this is going to do the square of all the elements present inside that particular array, right? So this is your array with scalar. I hope you are clear with this now. Okay. Now, in the next phase of this video, I am gonna talk about error versus warning in NumPy. Okay, what is this exactly? So what are errors first of all? Errors in this case are going to break the program. So for example, if I say 1 divided by 0, in NumPy, it is going to, in Jupyter Notebook, it is going to give you an error. So if I run this code, you can see that it tells us 0 division error in this case. So this is an error. It directly prints it is an error in this case. Okay. But when I say warning, let's say I divided 0 by 0. So in this case, let's say ARR divided by ARR. And if I run this code, you can see that because there were other elements also into the array which can be divided by itself. So they were giving 1, but only the first element was giving you an error. So instead of giving you an error in this case, it gave us a warning that other values are getting fine divided by itself. But the thing is that this value can't be done like that. And that is the reason it prints NaN for the missing value for that particular. It doesn't know what to do in that case. So it directly printed NaN. NaN means a none value or there is nothing there. All right. So this is a warning, guys. A warning will look in red like this. Okay. A red warning label like this, but an error will look like this. All right. This is how it looks like. Now, another type of thing that I can tell you is that if I say, let's say I divided 1 by the array itself. You see, in this case, rather than getting a nan value, I am getting an infinite value. Infinity it says, because when I divided 1 by 0, it gave me a infinite value. But for other values, it was giving me a nice value like this. So this is how an error versus warning looks like. So these are some different types of warnings that it is throwing towards us. But this is a error in this case because it is going to give you directly it'll directly break in simple words, right? So this is the difference between error and warning in NumPy and Jupyter Notebook, and I hope this is very much clear to all of you guys. So now the last part of this video, the third phase, universal array functions. Now what is a universal array function? So if I write here that NumPy comes with many universal array functions which you can use to perform different mathematical problems or operations. In this case, I'll say operations. What does this mean? So basically all the pre-built universal functions that are always there for you to use. For example, square root function, your exponent function, your max function, your trigonometric functions also. So all of those are actually universal array functions. And there are so many functions that you can explore on your own. So I'm just going to give you some few examples of the universal array function in this case. I can say np for numpy dot, and I can say sqrt. This is a function where I can pass an array, and this is going to give you the square root value of all the elements into that array. Here, dot sqrt is a universal array function which can be applied to the array in this case, and it is going to give the values of those elements from this particular array. So if I run this code, you can see that it gives us the value of all the square root values. All right. Similarly, I can work with the exponent also. So np.exp in this case, and I can pass array, and this is going to return you these values in this case. So this is another universal array function that we have you can use in this case. Then another function you can use is np.max in this case, and you can pass the array like this in this case, and it gives you the maximum value or the largest value or the largest element stored inside that particular array in this case, right? Or rather than writing like this, you can directly say ARR and dot, and you can say max on that. And this is also a universal array function which works with the array. In this case, we use the array and then we said dot, and then we access this max function, which was coming to us from this universal array functions. I hope this is very much clear now. Okay. Now, not only these kind of functions, but also trigonometric functions can also be used in this case. So for example, I can write here np dot sign of arr, and this is going to return the sign values of all the elements stored inside this array. So this like this you have different trigonometric functions also to explore. So this is all about your universal array functions. I hope you have understood this very well. Now if you want to explore more and more universal array functions, you can go to this website. I will give the link of this website into the description below, and you can click onto that link and you can see that this is a website which have so many universal array functions in this case that you can use. So you are have you in on this website you'll have the documentation and the usage with the code examples where you can actually go through this website and you can learn about different universal functions which are available to us from NumPy in this case. So you can see math operations we have, then we have trigonometric functions here. So you can use different trigonometric functions, how you can use bit widthing functions, comparison functions, and all these things in one place. So I hope that this is very much clear to all of you guys. So that's all for this video, guys. I hope you have liked this video. If you have any doubts into this video, tell us in the comment section below. I am gonna clear all your doubts, and that's all for this video, guys. So in this video, we have just learned about array with scalar, and universal array functions. And this is going to be the end of NumPy in this course. And this is all about NumPy that you need to know in order to proceed with different things that we are going to perform in this course. Well, NumPy is now a great ocean where you can find a lot of things and you can do a lot of things. But what I have told you in these NumPy videos till now are going to be the functions and the things that a normal data science user will most of the time use and most of the time in his work. Like these are the most commonly used functions which are used when it comes to NumPy operations. And this is how we work with NumPy. So that's all for this video, guys. Now, before we end this video, I would like to request you people again to please like, share, and subscribe to our channel Coders Arcade, and don't forget to press the bell icon so that you won't miss any future updates. So that's all for this video, guys. Thanks for watching. I'll see you guys in the next one. This is Ashang David signing off. I'll see you guys in the next one.